Are we together? Right. So, let's recap, let's just summarize what we've done. So the first thing is when you are dealing with a system, you must find the what? Equation of motion. In this case, we found it, and it's m plus, that's the equation of motion. Then being able to find the equation of motion, the next thing you want to find is from the system parameters. Now we are using the m and the k in the system in our equation of motion. Now we can be able to find natural frequency. So if for any system we can express it within something x dot dot, something x is equal to 0, automatically you now plug out this and that and you find the natural frequency. Are we together? Besides that, what else can you find? You can also find the frequency, which is equal to omega n over 2 pi. From there. Besides that, you can also find the period. 2 pi Right. Remember, I said the static deflection is a property of the system. So if it is a property, it defines whether the system is too stiff or it's too soft. And the softness and the stiffness of a system determines frequency. So you'll find that your delta can also come into these expressions. Are we together? Yes. Because it's a what? It's a property. Now, we had an expression. I rubbed it off, but at some point we had this expression. mg is equal to k delta. And we can say k over m from this expression is equal to g over delta. Can we see that? Check m there, delta comes there. Then we have this. Which means in these expressions, since we have k over m, we can also express them in delta. Which means we can say here this is equal to square root of k over m, g over delta. G over delta. Right? It doesn't go to the amplitude. It goes to the frequency. Similarly, 1 over 2 pi root of g over delta and 2 pi root of delta over g. Are we together? Right. On the other hand, you can see there is a link between amplitude and the disturbing displacement. Remember, x was a disturbance below the equilibrium position. So it's in the same expression with amplitude. This is the one that is related to amplitude. So you can find, for example, we have given initial conditions. We are not doing that now. We will do our own initial conditions when we have included damping. Today, we will skip that part. Otherwise, we're going to